Greetings to all individuals. Currently, we have a highly unusual video from a position that is equally unusual. I am taking photos while I am coming back from a visit to a client in the chemical pharmaceutical industry where I have been working on temperature control systems for reactors. It's a video I've wanted to make for a while, discussing how to calculate the thermal load or thermal power needed for an industrial process and how to supply or dissipate it. In this specific case, I am talking about how to calculate the thermal load in a reactor or in a chemical or pharmaceutical machine. Let's assume there are various kinds of reactors and machines, so the calculation can be performed in different ways. Usually we begin with the reactor volume that requires thermal regulation, depending on the type of product being processed in the reactor. Hence, it is essential to have knowledge of the physical characteristics of the product, particularly its specific weight and specific heat. Additionally, we need information about the heating and cooling curves, which include the initial and final temperatures, as well as the time required by the customer for heating and cooling the product. At this stage, you can observe that the calculation is a straightforward formula determined by multiplying the volume of the product by its specific weight, by the specific heat, by the temperature difference, and dividing it by the unit of time to determine the hourly kilocalories or kilowatt hours required for heating and cooling. Typically, this formula is utilized to analyze the various curves, the different temperature ascent and descent ramps, in order to determine which is the most demanding ascent or descent ramp. Consequently, based on this information, we can appropriately size our temperature control unit to meet the requirements of the identified ramp. Another kind of calculation is instead associated with control units that may be required to heat a reactor in which a distillation of a product is carried out. At this point, another calculation we can do to understand the potential or what is the reference potential for the sizing of the control unit, combined with the calculation of the temperature rise and cooling ramps, is that of distillation, that is, to obtain from the customer the information regarding the quantity in kg per hour of product that needs to be distilled. Evidently, with the latent heat of evaporation multiplied by the kilograms of product that are distilled per hour, the hourly thermal load that we must provide to the product with our temperature control unit comes out. Interesting topic, isn't it?